This is my lathe. It's a Colchester Britannia. I haven't been able to find much information about this exact model, but it's very similar to a lot of lathes produced in England around the early 1900s. I've owned it for nearly 10 years, and whilst it's been good to me, I definitely would have bought something different if I had my time again. I'd like to upgrade at some point, but I don't have the space at the moment. I haven't made any effort to clean it up, as that's sort of the point of the video. It has 4 main issues which make it very difficult to use, and as such I haven't been using it. I'm going to address those in this video. Firstly, storage. The base that came with it is nice and sturdy and has a large area under the lathe, as well as this little shelf. However, I've found that it doesn't really work for me. I tend to have everything crammed underneath, and things on the shelf accumulate dust and tend to be tossed haphazardly up there. I'm going to make some drawers to go under here, which should solve both of these problems. I also have quite a lot of scrap plywood kicking around the shop, so it'll help to solve that as well. Now, there's a lot of ways to make drawers, but if you just want to get them done, and you have a table saw, in my opinion this is the easiest. This also works for solid wood, I just happen to have plywood on hand. First, rip your stock to width. I'm going with 2 100mm drawers and one 140. I've marked the width and I'm adjusting the fence and checking the cut. Once it's set, it's very easy to cut out 4 pieces per drawer. Then cut the stock to length. The sides should be the length you want, and the fronts and backs should be the length you want, minus the thickness of one piece of stock. Now I set the blade height to half the thickness of the stock, and the fence to take off the full thickness of the stock. I then take a pass on each of the sides. Leaving the blade alone, I set the fence to the thickness of my bottom stock, in this case it's a slightly thinner ply, and run the bottom of each piece through. Now I set the blade height to the thickness of the bottom stock and the fence to half the side thickness, and run each piece through the other way, cutting out that rebate. This time, leaving the fence alone, I change the blade height to take off the thickness of the side stock and rip out those rebates. This is an awkward cut, but the ply cuts easily and the blade's so far from your hand that it's not really that dangerous. I then assemble the pieces with glue and brad nail them all together. The bottoms are just plywood rectangles which are glued and nailed on. I currently have my stock and scrap piled in this bucket and in this bottom shelf, neither of which is ideal. So I made a 4th drawer which will go underneath the lathe, which rolls on wheels on the floor instead of drawer slides to hold all of this stuff. This one has some cutouts in the corners for the wheels. I made up the wheel wells by cutting out some squares of a piece of 90/45 and shaping one into an L. I then glued them together along with a piece of plywood to get the height right, and drilled some holes in the sides to allow me to remove the wheel for maintenance. I glued them into the corners of the drawer, just using a couple of big screws and a small one on the bottom before putting the wheels in. Unfortunately, the plywood bottom I used was quite warped and it'll drag along the ground. So to combat this, I glued and nailed a couple of partitions into the box. These were just scrap I had kicking around that happened to have quite a concave edge, so by putting that side down it should suck the bottom up. I'm supporting the partitions on hardwood blocks and then standing on top of the upside down drawer to make sure the pieces are joined. It seemed to work really well. I got good glue squeeze out on both pieces, and now that it's dried you can see that the bottom is much more even. These are the drawer slides I got, nothing special. They were $18 each, which doesn't sound that bad until you realise that you need 3 sets for what I'm doing. They're a full extension slide, which will work well for what I'm dealing with. And to use them, you just use this little lever and pull out the bit which attaches to the drawer, and then this bit attaches to the cupboard. They come with a pack of screws, and there's some very interestingly positioned instructions, which so the glue is actually over part of the instructions. That's good. That's really good. Good thing you don't need to know what step 1 is. It doesn't really give you much in the way of instructions. It doesn't have any measurements or anything. It just tells you how to install it and uninstall it. So it's a little bit tight, but I think that'll loosen up over time as it gets used. Very happy. For the faces of the drawers, I cut some larger pieces out of plywood, which will close against the legs. I glued these on, and they'll also be held by the screws for the handles. For the drawer handles, I cut an angled block out of a piece of hardwood and then glued it back onto itself to give it a bit of extra width. I trimmed them to the right shape and cut them all to length. I measured up where I wanted them on the drawers and made a little jig to drill the mounting holes consistently. The motor on the lathe is controlled through this switch block on the front, which just controls a GPO on the side that the motor's plugged into. However, the reversing switch for the motor is super dodgy. I very rarely actually use reverse on this lathe, so it's more of a safety modification. First thing is to get the motor out of there. This is the belt tension screw. The whole thing pivots on a hinge bracket, which I'll unscrew next. I bought a 10 amp crossover switch. These are used to control lights with more than 2 switches. It takes 4 input wires and just swaps 2 of them around. And this is 2-core 240 volt double insulated electrical wire. All I'm doing is getting rid of the old dodgy wire and installing the new in the same location. While I'm at it, I'm also replacing the old power cable with a new one I cut off the end of an extension lead. I like using extension leads for power cables because they're cheap, rated for 10 amps, and they use a sealed plug rather than a screwed together one. For the switch itself, I'm just using an old architrave switch plate. That's going to be screwed onto this block, which is just a couple of layers of plywood with a hole and a slot for the wires, which will be screwed to the plywood bracket. I'm just giving it a test before I screw everything in place. Whilst it's out of the lathe, I'll give the bearing some oil. I don't have an oil can for these, so I'm just unscrewing the fittings and giving them a few drops. I won't bore you with watching the whole thing, but the no-load spin down time went from about 30 seconds to 43 seconds, so they definitely needed some oiling. And it works on the lathe. One last thing to do is mark the switch positions. I think that looks much better and safer than it did. This lathe originally used this older style of tool holder, which are a pain to set up. I bought a small quick change tool post for it, which is an improvement. However, because the originals have a drop on them, some of the new tooling won't sit at centre height. First, this boring bar. You can see even sitting on the compound, it's still a few mil above centre. I thought about milling this off with a lathe, but it doesn't need to be precise, so I'm just chopping it off with a reciprocating saw with a metal blade and finishing the edges with a file. Much better, and now it's got plenty of adjustment room. The high-speed parting tool blank I have is actually a tiny bit small for the holder, so even with the screws down it's not tight. Rather than order a new one, I'm just going to take a smidge off the shoulder. First I'll set up an ER collet with an end mill in the headstock, and then just put the holder upside down in the tool post. I just eyeballed the height and trimmed the shoulder off. One of the most important attributes of a metal lathe is the ability to make accurate, repeatable cuts. And for the most part this is accomplished by graduated dials on the lead screws, like this one on the cross slide. Unfortunately there isn't one on the top slide. The cross side dial is quite nice and unusual with the angled face, so I'm going to try and replicate that with the one I'm making. First I'll take some measurements and make a rough sketch and check the angle of the dial I'm trying to copy, which seems to be 45 degrees. I'm cutting this out of a piece of aluminium stock. I'm drilling the hole to be a nice fit on the shaft. I'm putting in a big counterbore to allow some room for the ball on the handle. I measured the marks on the dial I'm copying and found that they were roughly 100, 150 and 350 thousandths of an inch for the 1s, 5s and 10s respectively. Now I've got the issue of trying to do two precise tasks, moving the tool in and out 3 different lengths accurately and dividing the dial into 100 exact increments. To do the latter, I use Matthias Wandell's free gear generator on woodgears.ca, which on dividing head mode let me print out a 100-step ring. I had to print it over 4 sheets and glue them together, which was fairly easy to do. He does offer a paid program, which I may look at getting, which would allow for printing on 1 page easily. My idea is to mount a thin piece of MDF behind the chuck with a dividing ring glued to it. Now ordinarily for a simple part like I'm about to make, I'd just tell you what I did, but I got a new tool. It's the free donut, and who doesn't like that? Adjustable circle cutter. I chose the 300mm, and I'm not entirely sure that was a great idea. having this thing whipping around on the end of a drill might be a little bit terrifying. We'll see. Comes with a drill bit and a 4mm Allen key, which I'm sure is of the highest quality. Very good. I was hoping that I would be able to drill my thin asbestos. I wonder what that means. So when I bought this, I don't know why, but from the photos I thought it was going to be one of those ones where if you turn this, it's got a left and a right-handed thread on it so that it opens and closes the jaws or the cutting heads at the same amount. So you'd basically just set it to the right depth and it'd be fine. But instead, you have to unlock these. You can see I'm using my own Allen key already. Move them, set them to the distance, and then unlock the other one. Set that to exactly the same distance from the center, otherwise it's going to cut a slightly bigger or a slightly smaller hole than what you actually want. So that's a pain from the get-go. It comes with two inserts in here. So there's a little drill bit for thick materials and a little pin for thin materials. Now, I was like, I'll use this because I'm drilling thin materials. Look at the pin. Oh yeah, I'm going to have fun jamming that through 4mm of MDF. I would just cut that down on the lathe, but my 3-jaw is currently tied up with what I'm currently doing. One of the things that I didn't realise until I was already done setting it up, which was a bit annoying, is that there's a secret hidden Allen bolt in here, so this thing can move as well, which was a little frustrating because I'd already set this off the pin, and going side to side on each thing, it wasn't really measuring properly. But what was happening was this was slightly loose, so it was moving every time I was taking the measurements. Now that I know, it probably makes it slightly easier because you can just take your measurement off the two cutting faces and then move this to center, which is probably better than trying to take the measurements here and take the measurements here. This thing is also meant to be 7mm exactly, which it is right at the top, but the cut quality on this is just wow. Like, there's nearly 0.2 of a mil difference down in those ridges, and you can see it's actually got a little bit of a concave, so that didn't really help much either. Anyway, we'll go and set it up in the drill press and see how we go. On second thoughts, that looks absolutely terrifying. Maybe I'll just do it in the hand drill. There we go. Oh, Jesus. Alright, so that's on 1 speed. Let's, if I want any chance of cutting, I'm going to have to do it on 2. Oh yeah, that's not much better. But at least if I hit that, it'll hurt, and it might break my finger, but it won't take my hand off. Alright. Oh, jeez. Okay, so these motors short themselves out when you let go of the trigger, and there's so much inertia going on there that that's really locking the gearbox up. So I'm going to have to, if I'm going fast, I'm going to have to slow down gently to avoid that happening. Okay, this is a fun tool. I drilled out the center with the spinning bar of death and cut the circle with a bandsaw. I then glued the dividing ring to the MDF and mounted it behind the chuck. So here's the setup. I've got a couple of clamps holding a piece of wood with a screw sticking out of it, which I can line up with the marks. These are about 7mm apart, so any error I make lining these up by eye should be drastically reduced on the much smaller dial. I'm putting a piece of masking tape on the top slide lead screw as a temporary dial, which will show me roughly 0 and 50 thou. I've got a D bit in the tool holder centered on the work, and I've got a little checklist so I don't forget what each mark is. The 77 is what the cross slide is set to in case I need to back it out. Here we go. This looks tedious, but it actually goes fairly quickly once you get a rhythm going. Unfortunately, I noticed that the marks seem to be getting shorter. I set up the dial indicator and realised that having the disc behind the chuck threw the part out by about 20 thou. You can see I've marked how high certain spots are. I compensated for it by just slightly increasing or decreasing how far I fed the tool in, which wasn't the most accurate, but any error will only be cosmetic. Once I was done, I dismantled my setup, flipped it over, wrapped a bit of tape around it to protect it from the jaws, and finished the back. Right up till this point, it looked really good. Unfortunately, the number stamps I have are far too big. Not wanting to order some smaller ones, I decided to just go ahead. Holy cow, this operation took it from a professional looking part to amateur hour. Oh well, it'll do the job and I may remake it at some point. Last job on this was to drill and tap a cross hole for the lock screw. I went with the M5 as it was about as big as I could fit in the smaller ring part. Next up was disassembly of the top slide. A couple of screws allow it to come out, and then it's just a matter of undoing the lead screw from the nut. It looks like there's a pin holding the handle on. I wailed on it for ages with a hammer and punch and even tried heating it with no luck, so I just drilled it out. I think that there may have been 2 screws with the tops ground flush rather than a through pin. I welded up the holes in the handle and shaft, as well as adding a little extra material to the shaft to allow me to cut a thread. I ended up using a thread repair insert on the handle to limit how much I had to build up, and then I just cut the thread on the shaft with a die. I also drilled and tapped a hole in the end for a lock screw to stop the handle coming off. I also cleaned up the welds on the handle with a file and sandpaper. I made a steel ring with a single mark to replace the rectangular piece holding the lead screw in. This is cleaning up the back of it and facing it to final thickness. I marked the hole locations from the old piece and drilled them in the 4-jaw chuck. The screws are designed to be used in a hole that's countersunk by a larger drill bit, which is convenient. And final assembly. I'm just using some oil for both rust prevention and to try and keep everything moving nicely. And I've got the gibs tightened so that I can screw the handle on tight without everything moving. I started off by using a bit of cut-off O-ring at the bottom of the lock nut, but that didn't hold, so I instead used a tiny disc of brass that I cut from an old tap washer. I wouldn't go so far as to say that it looks good, but at least it's functional. When I first bought the lathe, I installed this desk lamp, but it was never good at applying light in the right spot. I bought these lights from Bunnings. They can be linked together, which is handy, because I don't want two cords. I want them to hang over the lathe and light it from two slightly different directions. I didn't make a plan or anything, I just threw pieces together until it worked. First I made 2 plywood strips to hold the lights, and marked out how I want them to attach the end plates. I nailed the end plates together and cut them out on the bandsaw, and then trimmed them to final width on the table saw. I glued and nailed the strips to the end pieces, and then cut a centre support from a thicker piece of plywood, which also got glued and nailed to the strips. The support arm, which is a thinned out piece of 7035 pine, has 2 plywood brackets glued to it and screwed to one end. The other end screwed to the centre support. The screws were a bit too long, so I trimmed them flush with an angle grinder. I attached the little brackets that came with the lights and then clipped them in, and a little bit of cable management to bring the wire to the back. The base and the upright are 2 bits of 7035 glued and screwed together at right angles, and then the support arm brackets get screwed to the top. I didn't glue this in case I want to change the height. I pre-drilled the holes in the base and then drove the screws right through the top of the lathe stand. It's a bit hard to tell in the video because the camera compensates for the light, but it makes a huge difference, and the slightly different angles mean that there's hardly any shadowing. The overall look is a little bit practical, shall we say, but it's above my head and I honestly don't really notice it while I'm using the lathe. This was never meant to be a restoration project, but honestly I think it looks a lot better than it did before. Just doing the work in this video made a huge pile of swarf, and I think that the 15 minutes I spent cleaning and tidying after finishing was more important than anything else I've done. I also gave the ways a good oil, which makes a massive difference to the feel of the lathe. I used chainsaw bar oil as way oil. The tackifiers which keep the oil on the chain and the bar are similar to what's used in proper way oil. I wouldn't use it on your $10,000 machine, but for this it's fine. You can see here that the bed's accumulated quite a few dings over its life. I ended up staining the front faces of the drawers and put a coat of varnish on them. I think they look really good. When I made the faces, I cut them all out of a single piece of plywood so you can see the grain running up through the drawers. I also put a coat of varnish on the inside to protect them from oil and grease. They're also huge. I've got all my general lathe tools in the top one, drills and taps in the second, and chucks in the bottom. The terrible plywood I used means that there's a couple of tight spots as you're pulling them in and out, which is unfortunate, but they do work. The bottom drawer was a bit of a failure. Because the room's carpeted, with the weight of the metal, the wheels sink and the whole base rubs along the floor. Given that it's filled with metal, it makes it a little bit hard to pull out. Pulling the carpet up might be high on the agenda. I'm slightly regretting my haste to dispose of the shelf. It'd be nice to have somewhere to put down tools during a project, so I might revisit that in the future. The lights are great, a little ugly, but honestly I don't notice it when I'm turning. The dial works alright, although I'd like a better solution than the lock nut. It's also ugly with the stamped numbers. I may have to do something about the cross-slide dial as well, because it's fixed to the shaft instead of being free to rotate and lock where you want it. It's a decent little lathe, cleaned up and working, but it's got some quirks. It looks like it's been cannibalised for parts at some point. You can see on the apron that there are a bunch of empty holes, which may have been for automatic feed. The cross slide has a cutout for a gear, and the lead screw has a keyway, so it looks like it had power feeds at some point, which is a shame, because I would really appreciate them. I can get some gears and use the half nuts, but the best ratio I can get is about 90:1, which works out to about 12 thou per revolution, which is a real roughing pass. Regardless, I'm glad that I've got it to this usable point. If you have any questions, or if you enjoyed the video, please let me know in the comments below. And thank you for watching.